Rich Harris, the author of Svelte, just dropped a discussion on an experimental async branch in Svelte. The long story short is you can now use the await keyword in Svelte, and it seems like it might be the first step towards some Svelte-flavored server components. He said it's a long document, so grab a cup of tea, subscribe to BetterStack, and let's jump in. Traditionally in Svelte, if a component needed data, it did one of three things. First, you might fetch that data in an onMount in Svelte, then you set the local state in that onMount, and then you use an if-else block to show the loading state, error text, or the actual data itself, as you can see here. So I refresh this page, we have that loading indicator, there's a 2-second wait on the API, and then you can see we actually see the data coming back. Now this works great, but every component starts to own its own spinner, and nothing really gets coordinated. The second approach is the await block. Now this does help reduce some boilerplate, but each request is still isolated. You can see here we set up the data promise in our script, then we do await data promise, we show our loading indicator, then we use the data once it's fetched, or we show an error message. If I refresh this over here, it does the exact same thing as the previous example. So if several components do this, they're still going to flicker separately. The third approach is to use SvelteKit and place the network calls in a load function outside of the component and on the server. This usually has the best user experience, but it does still have issues like prop drilling, type shenanigans, and reactive updates needing manual invalidation. So wouldn't it be great if Svelte allowed you to put that asynchronous work back inside the components with significantly better ergonomics and fewer drawbacks than the type seen in React, Vue, and Solid? Well, using the new experimental async branch, you can use await in 3 spots. First, we can now use await at the top level of our component in the script block. This makes it super simple as it's just writing normal JavaScript. We can simply just await our fetch call now, await data.json, and then we can use that result. As you can see here, we're seeing our loading indicator for 2 seconds, and then we get our data back. Now, the only requirement at the moment is any expression that might suspend must live inside of a Svelte boundary. You can place this Svelte boundary at the top level of your application, like I have here. As you can see, I've got my component inside of it. Now, apparently this requirement might be relaxed in the future. Using this new boundary though, we can actually show a one-time fallback via this snippet block here with pending. The second place we can now use await is in our derived expressions. As you can see here, I've simply got a data promise, which does the same thing we saw before of loading in my data. And then in derived here, I can simply await that data promise and the exact same thing happens. And again, we still need that Svelte boundary and that loading indicator. And the third place is simply in a template expression inside of our components. You can see instead of placing that logic in my script tag, I can simply place it inside of our template expression and I can just say await data promise. Now those were simple examples of just fetching data with this, but this is actually going to allow for other benefits like preloading images, lazy importing components when a user actually needs them, or just moving off CPU intensive functions to a web worker and then awaiting the result right inside of your markup. Now, in terms of performance, Svelte actually tries to do as much as possible in parallel. Like in this example here, you can see I'm making 3 different fetch calls and each one will take 2 seconds. If I go ahead and refresh the page here, you can see we see that loading indicator for 2 seconds as it made all of those requests in parallel. The same thing happens if we turn that into 3 components. As you can see here, if I refresh the page, we only wait 2 seconds as the async work has been done in parallel. In a script tag, of course, though, it will follow the standard sequence that you'd expect from JavaScript. On top of all of that, they've also made sure that all parts of the UI that read the same state are going to pause together, so you're never going to see your header update while your body is still showing old data. Even cooler though is they've made sure that things like a focused input that relies on some async work isn't going to pause and cause a really laggy experience for the user. The rest of the UI is actually going to catch up with the input. So that's our first introduction to asynchronous Svelte. Now the team's first goal here is asynchronous server-side rendering so that a boundary can render its real content instead of just a fallback. But this could also enable forking in SvelteKit, so it would speculate navigations off screen, then instantly commit whichever route the user clicks. But this could also enable client-server utilities, and this seems like our first hint that Svelte server components are coming. There we go, this looks like an awesome step for Svelte, and one that still manages to keep things simple. We're still writing normal JavaScript and just letting the Svelte compiler handle the rest. Now obviously this isn't production ready yet, it's still experimental. We'll probably see this enter its way into Svelte 6. Let me know your thoughts in the comments down below. While you're there, subscribe, and as always, see you in the next one.